We are going to be working on lesson 6.3 today. So if you have not already done your Spark, you'll want to go ahead and try out the Spark and then come back and see how I would do it. So at Winnie's restaurant, one serving of chicken soup is 1.5 cups. The chef makes 48 cups of soup each night. How many servings of chicken soup are in 48 cups? So when we're making a model, that means it wants us to draw something to represent this. So we know one serving is 1.5. And then I can see here that the chef makes 48. So I know that 48 is the total. So I'm going to draw this giant bar here and label it as 48 cups. And then I know that one person orders and they get a serving. That's 1.5. And then the next person orders and they get 1.5. So I can, if I keep on doing that, I can see the next person gets 1.5. And I'm going to keep on going until there's no soup left. So I can see that I'm actually taking my total of 48 and I'm dividing it by 1.5. So when you're making a model, you don't have to draw the whole thing out. Your model is just helping you see what are you doing. So once I can see this pattern of we're repeatedly taking things away, then I can see that that is a division problem. So here I would explain that I would take 48 and I would divide it by 1.5. And to divide by 1.5, you're going to need to make it an improper fraction. So I'll need to do 2 times 1 is 2 plus 1 is 3 over 2. So it does not like to write my 2's on here. So 48 over 1 divided by 3 over 2. So then remember, when we're dividing fractions, we want to copy dot flop. So we're going to copy the first fraction, change it to a multiplication sign, and then because we changed the sign, we have to do the opposite to the problem here. So 2 over 3, and then I can do that problem there. Okay, so here it wants you to click any of them that are the same as these, or looks like there's some other ones that are representing the same thing. And then make sure on your turn and talk that you tell me how dividing fractions is related to multiplying fractions. So that's a good reminder of some things we did last trimester. Okay, so we're going to start with task 1 here. So the past few days, we have been working on converting measurements between the same system. So feet, yards, inches, miles, that's what we use here in the United States. Things like gallons, cups, quarts, those are common measurements you'll find in your kitchen. Pounds, ounces, tons. So those are all the things we use here in the United States. So pretty much everywhere else in the world, though, they use, and that's called the Customary System. Pretty much everywhere else in the world, though, they use the metric system. And honestly, I think they might be a little smarter with that because everything goes in groups of 10, where ours are super random, 4, 16, like 2,000. Sometimes you're having to remember, where the metric system always is just nice numbers of 10, 1,000, 100,000. They're just always, every time it gets 10 times bigger. So, but we have what we have. We have the customary system. And sometimes we need to convert between the two. I might be measuring something here in America in pounds, but maybe I'm shipping it somewhere that they measure things in grams, of their weight in grams. So I need to be able to convert it over to see how much it is. So today we're going to be, and tomorrow we're going to be working on converting measurements between the customary and the metric. We're going to use that same strategy we've been using of what do we know is the unit rate, making that equivalent ratio, and solving for it. So here's the chart we're going to be using. And now these are not perfect. I can see here that an inch is exactly 2.54 centimeters, but the rest of these have that squiggly equal sign. So that means they're approximate. They're really close, but it's just not perfect. And so it's just as close as we can get here. So without making our math super complicated. So these have kind of been probably rounded, and because this probably keeps on going, so they just rounded it to a nice number for us to use. Okay, so be sure that you have a paper and a pencil and that you are doing these problems with me to help yourself learn. So that is something that you'll need to record on your chart at the end. So here is our chart we are going to be using. So task number 1 here says that Daniel is 6 feet tall. So we know we're talking about feet here. And he wants to know how tall he is in meters. So great example. So I am 5 feet 7 inches. And if I went to Disneyland Paris, so that is, over on a different continent on the other side of the world. And if I wanted to make sure I was tall enough to ride a ride, or some of the rides you can't be over a certain height. And if I wanted to know, they would measure over there in meters or centimeters. And so I would have to be able to convert my height into that. So on our chart, it told us that 1 foot is about 0.305, so 305 thousandths of a meter. So a foot is less than a meter. So let's just start and set up what we know. So we know we have feet and we know we have meters. So pause and write down what you know about feet and meters. So 1 foot is 0.305 meters. Now we're going to come to the problem and see what do we need to know. So I know Daniel is 6 feet tall, so I'm going to match up my 6 with my feet. Now I'm looking for the meters. So I can see we are multiplying by 6 here to get m by itself. So this problem here will tell me how many meters Daniel is. So go ahead and see if you can answer the questions on task 1. Okay, number 2. So this problem is a little wordy, so let's pull it apart together. So in the metric system, 1 gram is the mass of 1 milliliter of water. So grams measure weight. Mass is telling us how much matter is being pulled down by gravity. So a 2-liter bottle of water has a mass of 2 kilograms. So 2 liters weighs 2 kilograms. So every time you have 1 milliliter, it weighs 1 gram. See, theirs just works so nicely together. 1 equals 1. So if you have 2, it equals 2. Everything just works nicely together. So a gallon, now we're talking about gallons though. So that's what we use here in America. So a gallon of water weighs about 8 pounds. So if you pick up your gallon of milk, it's going to weigh about 8 pounds. What is the mass? So we're talking about what is the weight of a gallon of water. So this is where it kind of gets tricky. We're talking about gallons of water, but we're talking about the weight of a gallon of water, which we know is 8 pounds. So it sounds like we're comparing pounds and changing it to kilograms. Okay, so that's a lot of words here to get to the question. So 1 gram is 1 milliliter. So we don't actually need this information. A 2-liter bottle of water is 2 kilograms. We don't actually need to know that either. So a gallon of water is 8 pounds. So how many pounds is kilograms is what we're changing to. So on our table, it told us that 1 pound is 4.5 kilograms. So I want you to start your problem and see if you can set up your problem using this information here. Okay, so I know I'm comparing pounds and kilograms. So it tells me that 1 pound is 0.454 kilograms. So that's what we know, our unit rate. So now we're going to set up our equivalent fraction here. So what is the mass of 8 pounds? So 8 pounds to the nearest tenth of a kilogram. So we're going to multiply by 8 and then divide by 1 will tell us how many kilograms is in here. And now after we do this, this will give us, so I can see when I do 454 times by 8, it's going to have a decimal 1, 2, 3 places over. You're going to have 4 digits in your answer, and the decimal is going to be in the 3rd place over. Then our final answer just wants it to the nearest tenth. So that means we need to round it to the 10th place. So we're going to look back behind. And if this number is 4 or smaller, this number here will stay the same. But if this number is 5 or bigger, it's going to bump this number up. So this will be your final answer. Okay, so when you're doing your tasks on Ed today, you do not need to do method 2. So once you get to method 2, you can just go on and come back to the video and do task 3 with me. So go ahead and pause the video and complete task 2, just method 1 here. Okay. All right, so coming back, we are on our final problem for today, which is about these water bottles here. So many water bottles contain 16 fluid ounces or 1 pint of water. Drink labels often show the number of fluid ounces and the number of milliliters in a container. So if you are this company and you know how many ounces are in there, but you also want to put on your label how many milliliters are in there, you've got to be able to do this conversion rate. So we know we're comparing milliliters and ounces. So milliliters and ounces. So I can see in 1 ounce that there are 29.6 milliliters. And it wants to know how many milliliters are in 16 fluid ounces. So we need M by itself. So we're going to times by 16 and then divide by 1 will give us M by itself. That should say task 3. Okay, so after you have that, go ahead and see if you can answer the questions on task 3 and then complete your check for understanding. If you have any other questions about your tasks today, please let me know.